So are you now able to see my screen?
Yes.
All right, so today's topic is matrices, chapter 5, right?
Yes.
Now, what exactly is a matrix? So I am on page number 216 at the moment, which talks about,
Let me just.
which gives us a very brief introduction of what matrices is and let us know how we use it on a daily basis. All right.
Yeah.
So, see, if you see matrices is a plural of the word matrix,
Okay.
and matrix is nothing but it's a rectangular arrangement of some numbers. Okay,
Okay.
so I'll take a black here. All right. So, matrix. So matrix is a rectangular group of numbers. So I can say 1, 2, 3, 4. Right? Now what are these numbers? Basically, matrix helps us to store information and helps us analyze the same. Okay,
Yes.
and it is very useful in our, it has a very practical application, as in
Yeah.
it helps us to, as I said, analyze information. It helps us to resolve problems. It helps us to solve, especially from a mathematics perspective, it helps us to solve. It is also one of the ways of solving simultaneous equations.
Okay.
You remember we did equation solving by substitution and equation solving by elimination, but matrix
Yeah.
is another way of solving simultaneous equations. Okay,
Okay.
now let us consider an example that you are in a supermarket which sells probably two products. So you say
Okay.
a supermarket, should I say Coles, it sells
Okay.
two products, let's say bread and
Okay.
butter. All right.
Okay.
Now
Okay.
on a Friday, let's say the breads, there were around 500 breads that were sold and 200 butters.
Okay.
And on a
Okay.
on a Saturday, let's say 1500 breads were sold and 500 butter. Okay.
Okay.
Now, if
Yes.
I club this information into a rectangular matrix, within a rectangle, to sort of
Okay.
form a matrix, it gives me a sort of a matrix look now. You see? Yes?
Okay.
It looks like a matrix.
Yes.
Now, if
Yes.
I ask you, now this is the information that I've now stored in a matrix. And if I ask you that, tell me how many butters were sold on a Saturday, looking at the matrix.
500.
Yep, you arrived at this number straight away. You said butter, Saturday, that's the number, right?
Yes.
Now, if I ask you how many breads in total were sold over Friday and Saturday, so what do? You add these two numbers, right? And you can give me the
Yes.
answer like a 2000, right?
Yes.
And if I ask
Yes.
you how many butters were sold on Friday and Saturday, so obviously you can do the same stuff. And
Yes.
you can say 700. So you see, we stored the information in a matrix format, and that helps us to analyze the same information in different ways. Yes?
Okay.
So that
Yes.
is primarily what a matrix is, what matrix is all about.
Uh, another one is like, what does it say there? Solve simple equations.
It can solve simultaneous equations. Sorry, I just used the shortcut here. So solve simultaneous equations, right?
Yes.
Yeah, don't worry too much about writing it down. I think understanding is more important. You can use your pen and paper when we are actually jumping into solving the actual questions, right? Don't worry too much about it, right? It's mainly about understanding at the first point. All right.
Yes.
Okay. Now let's pick up the next topic on matrices, which is something called very important, which is called order of a matrix. Okay. Now,
Okay.
I use the same example, the bread and the butter example. So we were like what, 500, 200, 1500 and 400, right? Or 500, whatever. Right? Now,
Okay.
if you see the horizontal, so if I change my color, so these are the red, the ones that are encircled in red. These are called rows. Yes?
Okay. Yes.
So here, how many rows do I have? I have 2 rows,
Two
row
rows.
1 and row 2. Yes?
Okay.
Now let me change
Yes.
another color to differentiate it a bit more. Now if I see the stuff which is encircled in blue, so can I say them as column 1 and column 2? Yes?
Yes.
So a matrix is a group of rows and columns.
Okay.
All right?
Yes.
Now and these rows and columns are actually the ones that define what we call as the order of a matrix. So here if you see,
Okay.
how many rows did we have? We've got 2 rows, right? And how many
Yes.
columns do we have? We've got 2 columns. So the
Yes.
order of this matrix is 2 cross 2. So the
2
order
cross 2.
so the order of matrix is always represented starting from rows cross columns. So it's always R cross C, which is the row cross columns. Got it?
Okay. Yes.
Now it could now matrix can have any number of rows and any number of columns. So
Okay.
so if I write something like this, 5, 4. Now can you tell me what is the order of the matrix? I mean, I'm interested in knowing what is the row cross column combination here. So how many rows it has?
1 row,
Yep. And how many columns does it have?
1 column.
No, it has got 2 columns. You see one here and one here.
Oh, sorry. Okay. Okay.
So
2 columns.
columns, as I said, again I reiterate, rows are horizontal.
Okay.
You see? And columns are vertical. Just like in Excel, right? In Microsoft Excel,
Yes.
it's a combination of rows and columns, right? So all the horizontal lines are called rows and all the vertical lines are called columns. So if I see my matrix here, and every matrix is determined, is denoted by an alphabet. So I can call matrix as A equals 2. So I can call this as matrix A has 2 elements. So another piece of information, the individual numbers inside the matrix are called elements. Okay, so we've got 2 elements in total, 5 and 4, and these 2 elements form 1 row which is one horizontal line and two
Yes.
vertical lines. So that means 1 cross 2.
Okay.
Make sense? Make sense? Your voice is...
Yes.
Yeah, cool. So the order is 1 cross 2. Okay, let's do another example. Now, if I write something like this, 5, 4, and 3. Now, you tell me what is the order of the matrix. So I'm interested in knowing row cross columns.
Wait a minute.
So how many?
So there's 3 rows
Awesome.
and 1 column.
Great. So we've got 3 rows. We've got row number 1, R1, row number 2, and row number 3. And we've got just 1 column here, which is C1. Right? So that's why the order of the matrix is 3 cross 1. Make sense?
Okay.
Awesome. Let's pick up one more example. Now, let's see what you would answer here. So if I've got something like this. Now, tell me what is the order of this matrix? You've got just one element in that matrix, which is 5. Yeah, what's the order?
1 times 1.
Yes, great. So
1
you've
cross
got,
1.
yes, you've got 1 row, row 1, and 1 column, column
Yes.
1, right? So that's 1 cross 1
Yes.
matrix. Make sense?
Yes.
Awesome. Now, let's talk about the element numbers. Let's talk a bit more on probably on elements. Now, let us say I've got a matrix here. 5, 4, 3, 2, 1, 4. All right. Now, can you
Yes.
can you tell me quickly what is the order of the matrix, please?
So 2 cross 3.
Yes, great. So we've got a matrix which is of 2 cross 3. Now, if you see, I'll change the color here. So that's the row number 1, correct? That's row number 2, correct?
Yes.
That's column number 1, that's column number 2, that's column number 3, correct?
Yes.
Now,
Yes.
the first element
Yes.
is A11. I denote individual elements as A, and the first number here represents the number of row, the row number, and the second
Okay.
number represents the column number. You see, it's A11, right?
Yes.
Now, what would be this number? A. This would be A.
A.
What is the row number?
A. A2.
No. What is the row number?
A3.
No. For this element here,
Row number is 1.
row number is 1. What is
A12.
awesome? So that's A12.
Column is 2.
Yeah. What is this? Come on, give me this one now. The third one.
13. A13.
A13. Great. Give me this one, please. The next one.
That would be A21.
Awesome. This one.
22.
A22. Great. And this one?
And A23.
2, 3. So that is how you number various elements within a matrix. Now,
Okay.
Another quick concept around elements. There's something called diagonal of a matrix. Okay, so do you remember,
Okay.
if we go back to our geometry, so if I've got a rectangle or a square, what is the diagonal? That's the diagonal, right? The line that
Yes.
joins the opposite vertices. I mean, vertically opposite vertices, right? So we've got two
Yes.
diagonals here, right? So similarly, if I've got a matrix
Yes.
like this, 5, 4, 2, 3. So I have got, so that's my diagonal here. That is my diagonal. Okay, I've got just one diagonal
Okay.
here, so that's my diagonal. So if I were to name the elements here, so this will be A11, yes, and this
Okay.
will be A12. Am I correct?
Yes.
This will be A21, and this will be A22. Yes.
Okay.
So if
Yes.
if you see the elements along the diagonals, are always A11, A22, A33, A44, and so on, depending upon the order of the matrix. Got my point?
Yes.
So that's the element numbers along the diagonals. Got this concept?
Okay.
Sure?
Yes. Yeah.
All right.
No.
Now, what's the problem? Tell me.
I think it's from what you just said. Elements along diagonal set. I didn't
So
get
now,
what
all right,
you meant by
okay,
the number
okay.
A11,
Let's
A22, A23.
go here. Let's go here. All right. Let us say this matrix is a 3 cross 3 matrix. Now you're going to be telling me here, right? Okay. Let us say this matrix.
Okay.
Let's say this is a matrix A, which is a 3 cross 3 matrix.
Okay.
Now, what would be the first element here? Element number. Will it be A11? Yes. I don't care about the value. I'm more
Yes.
interested in knowing the element number. Correct? So,
Yes.
what would be the next element? Come on, give me the next element.
1, 2.
Awesome. Give me the third element, because it's a 3 cross 3. That means we've got 3 rows and three columns. So, A,
1, 3.
1, 3. Good. Now, give me the second. Now, give me the element here.
A2, 1.
Good. Give me the next one.
A2, A22.
Give me the next one.
A23.
Awesome. Give me this one.
A31.
Good. Give me this one.
A32.
Yep. Give me this one.
A33.
A33. Right? Got it? Now,
Yes.
if you see, this is the diagonal.
Okay.
That's the diagonal of the matrix. Yes? The elements that are
Yes.
here. Now, can you read all the elements of the diagonal, please? The first element of the diagonal is? Look at the picture. And
A11.
you see, that's what I've written. A11. What's the next one?
A22.
Yep. What's the next one?
A33.
Yep. You see? So that's what I'm saying. So it is a 3 cross 3 matrix. So you have to end at 3, 3. But if this would have been a 4
Okay.
cross 4, you would have an A4, 4 as well. If you might have a 5 cross 5, then you might have a 5, A5, 5, and so on. So what the point I'm making here is that the element numbers on the diagonals have the same row number and the same column number. You see A11, A22,
Okay.
A33. Correct?
Yes.
You got this point? So now if
Yes.
this would have been a 2 cross 2 matrix, you would have ended at A11 and A22. That's it.
Okay.
Yes? Yes or no?
Yes.
So for illustration purposes, I'm writing it down for you. So if I've got a 2 cross 2 matrix, let's say B is a 2 cross 2 matrix, and I would write A12, A22, A21, sorry, this is A11, sorry, A11,
1 1.
let me just, A11, A12,
Yes.
A21,
Two,
and A22,
1 8 2 2.
right?
Yeah.
And you see my diagonal here, that's my diagonal.
Yes.
So here I've got, in my diagonal, I've got A11 and A22 only.
Okay.
Yes?
Yes.
Got my point?
Yes.
So that's the concept of diagonals in a matrix. So you've got
Okay.
only one diagonal in a matrix, which goes from
Yep.
top left to bottom right. So this is top left
Okay.
and this is bottom right, correct?
Yes.
All the elements, so in a nutshell, all the elements which fall diagonally from top left to bottom right are the elements of a diagonal in any matrix. Make sense?
Okay. Yes.
Perfect.
Yes.
All right. So that was on diagonals. Now let me just flip to the book and see what we haven't covered. So we've covered the order, we've covered the elements. All right, let's cover something called a square matrix and row matrix and column matrix. All right.
Okay.
So now we've understood what a matrix is, what is a row matrix, what are the elements, what are the diagonals. Now we'll study something called
Basics.
the row matrix,
Okay.
the column matrix, and square matrix.
Okay.
All right, let's talk about the row matrix first. Right? So, row matrix is that matrix which has just one row. It has just one row only. Okay? You see on page number 219 of your book, you've got row matrix
Yes.
which has just single element. So if you see here,
Yeah.
on page number 219, so I can draw down one for you. So for example, if I say A equals to 1, 3, 7, can you give me the order of this matrix, please? What's the order of this matrix?
1 cross 3.
Awesome. So how many rows do we have? Just one.
1
right?
row.
So any matrix that has just one row is called row matrix.
Okay.
Now let's talk about the column matrix. Now, column matrix. So as we defined row matrix, on the very similar note, we can define column matrix. So any matrix which has just one column only
Yes.
is called column matrix. Now, can you tell me what is
Okay.
the order of matrix B that I've just written here on the whiteboard?
3 cross 1.
3 cross 1. You see how many columns do we have? Just one, right?
Yes.
So that is called column matrix. Let's talk about, all clear so far, both the matrices?
Yes.
Let us now talk about square matrix. What is a square, Joseph?
Four
What
numbers in it, like
the square what is a square? Square has equal sides.
4 sides, 4 equal sides.
Equal 4 sides, right?
Yes.
If I have to draw a square, this is a square. So if suppose this is 2 centimeters, so all of them are 2 centimeters, right?
Yes.
So a square matrix is nothing but that matrix which has same number of rows and columns.
Okay.
Okay? Got this?
Okay.
So it could be, if I draw this matrix, let's say, now you tell me if I draw something like this. Now can you give me the order of this matrix, please? With just one element in it?
1 cross 1.
Yes, 1 cross 1. You see, you've got one row and one column. So this is a square
Yes.
matrix. Now I draw another one. Now can you give me the order of this matrix?
2 cross 2.
Yeah. So you see 2 rows and 2 columns. This is also a square matrix. And if I draw
Yes.
something like this, 1, 2, 3, 4, 5, 6, 7, 8, 9. Can you give me the order of this matrix, please?
3 cross 3.
Yep, that's a square matrix as well. So your square matrix is in the form of n cross n. That means whatever will be the number of rows, same will be the number of columns. Okay, and I can go on making it like a 4 cross 4 or 5 cross 5 or 6 cross 6 and go on till any number that I wish to. Okay,
Okay.
make sense?
Yes.
All right, so we talked about square matrix. We are, so far we are done with 5A. Okay, but
Okay.
before jumping onto 5B, I'll jump to 5C. So you're clear so far? And I'm pretty sure that you can easily attempt all 5A questions. Do you want me to
Yes.
you want to try one by any chance? Just to check you understand it?
Yeah, I can try.
All right.
Yes.
So let's quickly go to 5A and can you quickly do question number 8 for me, please? Let's try question number 8.
This is 5A.
5A, question number 8, and I'm on page number 223.
Just look at your. Just look at your screen.
Yeah, go for it. So it says matrix F shows the number of hectares of land used for different purposes for farm X and farm Y. All right. Now rows, now your rows represent here, your rows represent the farm X, row 1 represent farm X, and
Yes.
row 2 represent farm Y.
Yes.
Okay. Now it says your column 1, 2 and 3 represent wheat, cattle and sheep. That's represented by W,
Yes.
C and S. Alright. Now
Yes.
let's do question number 8A. First part. Farm X, can you tell me how many hectares of land is used for farm X for sheeps?
Farm X for sheep is 7 hectares.
75. Yes?
Yes.
Farm X for cattle.
Cattle farm X is 300.
Awesome. Farm Y for wheat.
Farm Y for wheat is 200.
Awesome. If I jump on to, say, question number C, part C, can you tell me what is the
Yes.
information that's given by the element F22? Which is F22?
F.
Now, second row, second column. That's how you decipher.
0.
0. So what does
Yes.
that what does that represent in plain English?
0 hectares.
So how do you interpret that into plain English? What information it gives you? So can you decipher that?
I didn't get that. Can you repeat that?
So you've deciphered that the information that we are talking about is 0, right? Now what is this 0?
Yeah.
This 0 is for farm Y and C is for cattle, right? So how we decipher this information is that farm Y uses 0 hectare land for cattle. Make sense?
Okay.
That's how you write it, okay? In your exam.
Okay.
Make sense?
Yes.
All right. Let's do F13, first row and third column. So what's the value first row and third column?
First row and third column is so farm X uses 75 hectares for sheep.
Awesome. That's what it is. And if I jump onto 8D, part 1. Now it says which element in matrix F gives me the number of hectares used for farm Y for sheep? What is the element number? Farm Y for sheep.
Number for sheep. So it is 2 F
Yeah.
2 3.
Awesome. That's how you do it. And can you just state the order of matrix F?
Order.
Yeah.
Wait.
What is the order of matrix F?
F it is 2 cross 3.
Brilliant. So that is what 5A is pretty much all about.
Okay, it's
Got it?
straightforward.
Very straightforward.
Yes.
I'm now jumping on to 5C, which talks about addition
Okay.
and subtraction of matrices.
So is 5B just like 5A?
5B is pretty much same as 5A, but yes, slightly on a different, at a concept level, slightly different. So that's why I wanted to cover it more towards the end. Yeah, but that's not very difficult, to be honest. Yeah, but since I wanted to continue on the lines what we've been studying so far. So 5C falls in line, I should say.
Okay.
All right. So now what we are going to learn is something called the addition and subtraction of matrices. The addition and subtraction of matrices is very, very simple. It normally is done, I mean, it's followed like the way we add or subtract regular numbers. All right.
Okay.
Okay. Now, the very, very basic and the ground rule for addition and subtraction of matrices is that the order of the two matrices that we are adding or subtracting should be same.
Okay.
So that means if I am trying to add a 2 cross 2 matrix with another matrix, the other matrix has to be a 2 cross 2.
Okay.
And why that is the case, let's quickly see an example. So I'm putting two matrices and I'm planning to add them. So I'm just randomly putting any numbers here.
Okay.
Okay. Now, what is the order of the first matrix? Can you quickly give me what's the order of the first matrix that I've written?
2 cross
2 cross 2. So this is a 2 cross 2 matrix. And this is, the second one is also a 2 cross 2 matrix. Yes? Now, why I said that the order of the two matrices have to be same is because addition or subtraction happens at the element level. So, first, the elements add or subtract from each other individually.
Okay.
So that means if the first element here is A11 and here it is B11, so A11 and B11 have to add together. So here, this 1 will be added to this 1, this 2 will be added to this 3, this 3 will be added to this 4, and this 4 will be added to this 5. So you see, we are dealing at an individual element level. So that is why the order of the matrices is very important, so that every element is dealt individually. And if we've got, now I'll come to the addition, but for example, if I've got something like this.
Okay.
Now this is a 1 cross 2 matrix and this is a 2 cross 2 matrix. I cannot add them. Why?
Yes.
Because there are no corresponding, I can add 2 to 4, I can add 3 to 5, but I have elements missing out here. So these elements have no corresponding elements back here. Right? And that is why I can't add or subtract them. Got my point? Got my point?
Yeah. Yes.
Now, if I have to add, let's go to the original example where we were trying to add a 2 cross 2 or 2 cross 2. Can you start giving me the individual addition elements in the final matrix? What would be the first element? If I add 1
2.
plus 1 would be 2. Great. Give me this element here, A12. Give me A12.
5.
Great. Give me A21.
7.
Awesome. Give me A22.
9.
Yes, that is 9. So you see, that is how you add two matrices. And the rule stays pretty much the same for subtraction as well. And I tell you, you've got to apply the same logic for addition, subtraction, even if the numbers or the elements are positive or negative. Let's take an example. Let's take another example here. So I'm picking two 2 cross 2 matrices. So let's say my elements are -1, 2, -3,
Okay.
4, and here I've got 6, -5, -2, and let's say -1. Now can you start giving me what is the first element? What is A11, please? Your -1 plus, so we are saying -1 plus 6. What's the answer?
5.
Cool. So answer is 5. Great. The next one, A12. So I'm trying to add a 2, -5. What's the answer?
-7.
-3, baby. -3.
Okay.
Right? Give me
Oh, the next one is negative.
-5. Yes, correct. And what is the last one? That's simple. 4 minus 1.
3.
3. So you see,
3.
the rules for addition, subtraction still remains the same. It's just that you are dealing those at an individual element level.
Okay.
Make sense?
Yeah.
So that is what is addition. Now if I were to, let's take an example for subtraction, pretty much the same. Let me use a black color here. So let's say if you've got 1, 2, I'm taking a very basic and a simple one. Let's say 3, 4, 5, 6. All right, now can you start giving me the elements? So first one is 1 minus 3. What's the answer?
1 minus 3 is -2.
Great. Next one, 1 minus 4. What's the answer? Negative
Are you 2
3.
minus 4?
-3. Yeah, makes sense. This is -3. This one?
Wait. Why isn't it 2 minus 4?
Ah, my bad. Yeah, correct. Thanks for that.
Yeah.
Yeah, so it's 2 minus 4. Correct. Thanks for correcting. So it is -2. Right? Again? Makes
Yes.
sense? All
Yes.
right. Next
Yes.
one. 3 minus 5. What's the answer?
3 minus 5 is
-2 again.
-2.
And what is 4 minus
4.
6? You see the coincidence?
-2.
-2. So that is how you deal with subtraction. So the rule of the game for addition and subtraction doesn't change. It is just that we are dealing with two matrices at an individual element level.
Okay.
And the most important part is, I'm writing it again, the order of the matrix. Matrices should be same. Make sense?
Yes.
That is what, if you see, your 5C is all about. Now, one point that I missed out is there's something called a zero matrix.
Okay.
Let's see what is a zero matrix. Suppose I've got, let's say, two matrices
Yes.
that I'm subtracting with each other. Let's say 1, 4, 5, 1, 4, 5. Can you just give me the final matrix, please? What is the order of this matrix? Come on, give me the order first.
1 by 1 by 3. 1 cross 3.
Awesome. And this one?
1 cross 3.
Awesome. Now, can you start giving me the elements? If I subtract the two?
Elements 0, 0, 0, 0.
Yeah. So any matrix that has all elements as 0, irrespective of its order, is a 0.
Yes.
Is called a 0 matrix. So this is a 0 matrix.
Okay.
Make sense?
Yes.
Sure?
Yes.
All right. So I think we've covered 5C as well. So 5C simply talks about addition and subtraction of matrices.
Okay.
All right?
Okay.
Make sense?
Yes.
All good. Any doubts so far?
Okay.
Any doubts so far?
No.
So,
It was all understandable.
yeah. So what have we learned so far? So I'll quickly recap. All right. So I'll revisit all my sheets now. Okay. So what is a matrix? Matrix is an arrangement of numbers in rows and columns. It helps us to store information and hence analyze information, and it also helps us to solve simultaneous equations. This is the last bit. This is the last bit that we'll cover. Okay. So for example, in the example here, we had a bread and a butter example sold on a Friday and Saturday in a Coles. So that's how you arrange. So 500, 200, 1500, 500. That gave us various sort of information. So for example, a bread, how many breads were sold on a Friday and Saturday? We added them up, and so on and so forth. So basically, matrix is an arrangement of information in rows and columns. Then we talked about the order.
Yes.
So matrix has rows and columns, and the order is always calculated or written in terms of rows cross columns, right? So you cannot have columns cross rows.
Yes.
So that will be incorrect. So if I say my order of a matrix is 2 cross 2, that means I've got 2 rows and 2 columns.
And 2 columns.
If I've got just one element in it, so that means I've got just 1 row and 1 column. So my order is 1 cross 1. All right.
Yes.
Next one, we talk about elements. So if I've got a matrix A, which is 5, 4, 3, 2, 1, 4, so that's how your elements are represented. So your element, this number here underneath the elements is nothing but the first number tells you the row and the second number tells you the column. So if I write A13, so that means element on row 1, column 3. Make sense?
Yeah.
And a matrix has a diagonal which is from its top left to bottom right, and all the elements on the diagonal have same row and column number. So if it is a 2 cross 2 matrix, you could have A11, A22. If you've got a 3 cross 3 matrix, you could have A11, A22, A33. Yeah, make sense?
Yeah.
All good?
Yeah.
All right. Then we talked about what? We talked about column matrices,
talked about the
row matrices, and
row matrices and square matrices.
And square matrices. What is a row matrix? Can you tell me what is a row matrix?
There's only one row.
Yes. And it could have any number of columns. And what is a column matrix?
Yes. Column matrix is only one column and could have any number of
Awesome.
rows.
What is a square matrix?
Same number of columns and rows.
Awesome. So if I've got an order of matrix, let's say if I've got a matrix with 4 cross 4 matrix, would this be a square
Yes.
matrix or a row matrix or a column matrix?
It would be a square matrix.
It would be a square matrix. Cool. And then after we've understood what's a square matrix, row matrix, column matrix, the basics of it, we jumped on to addition and subtraction.
Yes.
So addition of subtraction means, the basic rule, the most fundamental rule for adding or subtracting is that the order of the two matrices that we are dealing in have to be the same. And the elements are added or subtracted just like normal numbers. They follow the same rule of arithmetic when we are doing, when we're dealing with positives and negatives, right? But it's done at an individual element level, right?
Yes.
So that basically is addition, subtraction of matrices, and that's what we've sort of covered today. Yeah.
Yes.
So I will just add one more topic today on the basics of matrices, which is called exercise 5D, which is called the scalar multiplication.
Scalar multiplication.
Yes, scalar multiplication.
5D.
That is 5D. Okay.
Okay.
Now, scalar multiplication means if I want to multiply my matrix with any number. So, for example, if I'm just drawing down two matrices here. Let's say my matrix A is 1, 2, 3, 4 for simplicity, and I've got another matrix B as 1, 2, 3. Now, can you quickly give me the order of this matrix, please, Joseph? The first matrix A.
2 by 2. 2 cross 2.
Cross 2. Great. And the second one, matrix B?
3 cross 1.
Awesome. Now, if I write something like 3A. Yeah, if I write something like 3A, that means I'm multiplying 3 to matrix A. Okay. So what does that become? So I write 3 outside and I write the value of A matrix here. So what is A? 1, 2, 3, 4. Right? And the way I did my addition and subtraction at an individual element level, I will do the same with scalar multiplication. So that means this 3 is getting multiplied here. That means this 3 is getting multiplied to all the individual elements.
Okay.
So my final matrix would be, now 3 times 1 is 3. 3 times 2 is 6.
Yes.
So everything is getting multiplied by 3.
Okay.
You see, that is what is the answer for 3A.
Yes.
Got it?
Yes.
Now, if I do a similar multiplication, let's say I say negative 2B. So what I would do is I would place a negative 2 outside and I will write my B matrix here.
Okay.
And then I will multiply negative 2 across all the individual elements.
Okay.
So what's the answer? Come on, give me the answer. What's the first element become?
Will be negative 1.
Negative 1 times
Negative 2.
negative 2. Great. What's the next one?
-4,
Great. What's the
-6.
-6? So that is what scalar multiplication is all about. Now, got my point?
Yes.
So in scalar multiplication, we are just multiplying the elements individually to any number which is placed outside the matrix.
Okay.
All right.
Yes.
So that pretty much, finishes the very basics of matrices. Obviously we'll go to the next step from here on, which probably
Yes.
I'll like to cover in the next class, is the actual multiplication of matrices and the application of matrices. So we've sort of
Okay.
done until 5D. So I would advise,
Yes.
you get some hands on 5D until 5D. Skip 5B, so try 5A, 5C, and 5D. And in the next 5A,
Wait, can you say that again?
5A, 5C, and 5D. So
5A, C, and
D. So
5D.
do the
And-
basics of matrices, do addition, subtraction, and do scalar multiplication.
Just few questions, yeah?
Yeah, try all the questions, and they're pretty straightforward, I tell you. After we've covered this one, that's pretty much the application of what we've learned today.
Yes.
Yeah,
Yeah.
cool, all good. So we are, I think, done with very basics today.